Hello everyone, I'm Kong from Aeon Sparks Interactive. I'm the CEO and founder of this indie game studio from Malaysia. We have been using Unreal Engine for developing our own indie games and mobile games for quite a few years. We have used Unreal Engine for various types of games development, from casual games to hardcore actions and racing games. Unreal Engine has been a pleasure to work with. We love the scalability of the game engine to be able to handle a wide range of hardwares. We spend less time on technical issues and we can be able to focus more on the creative contents of our games. Today I'm very glad to be here to be able to show you guys some of the tips and tricks that we have applied in optimizing our own mobile games with Unreal Engine. In this session, we will show all of you the collective techniques and ideas we have learned over the years of production experience in delivering our mobile games. Hopefully our sessions today will be beneficial to aspiring mobile games developers. Why do we need optimization? Optimization is much more crucial, especially for mobile platforms. Performance, package size, memory usage, compatibility, flexibility, and overall gaming experience are all important aspects to be considered for the optimization process. Our team approach towards optimizations usually involves the following procedures, including strategy and evaluations, assets optimization, code optimization, rendering optimization, debugging tools, and package methods. First off, we would evaluate our target hardware specifications, determine our asset budgets, and then perform a stress test to measure performance levels. As a start, you will want to set your target quality of your game, followed by minimum hardware requirements. You should also decide on the control scheme, whether or not it should be a touchscreen or controller. As for asset budgets, we list all the assets required into an asset list. We set a maximum budget located for the polygon counts in triangles and texture size in pixels. Just remember to stay frugal and don't go too generous with the budgets. When we are making performance stress tests, we make a white box gameplay with placeholder assets based on allocated polygon and textures budget. Testing on actual target hardware for compatibility and performance verifications. And we are also checking from time to time in the profiler for performance results. Having that, we can adjust the asset budgets if required. Here's a very simple game called Food Brawl that we have worked on. In the earlier stage of the process, we try to use white box to gauge the amounts of budgets we have for the enemies. As a result, it's helped us to find the budgets pretty quickly and we don't have much trouble with optimizations for the final delivery. Next is Race Room Mobile. It's a game with a lot of challenges in optimization. We have to squeeze as much high-quality assets as possible in the game. Having a white box prototype in the beginning, we immediately noticed the challenges ahead. And we have to build our optimization strategies earlier on, even before we can start the actual game development. Thanks to all the extensive tools available in Unreal Engine to our disposal, we are very happy to report that the game looks amazing in the final results. Finally, this is a console and PC games that we are currently working on called Zombie Soup. We did a lot of stress tests with AI enemies many moons ago before we started our production. Due to the strategies we have planned beforehand, we are very confident that this game will be easily ported to mobile phones and tablets when we needed to do so. Once we have decided our strategies, we'll continue the actual work for asset optimizations on poly counts, texture size, format, and sprite packing. We reduce poly counts by utilizing level of details or LODs. Unreal Engine will automatically swap its LODs with lower poly counts assets, which is further away from the player cameras. By leveraging Simplygon Mesh Simplifications algorithm, we can optimize our polygon assets by just a click of a button under Regenerate LOD in Unreal Editor. Then it will seamlessly create multiple levels of LODs for both skeletal and static mesh. We always use the power of 2 for the textures, UI sprites, and animation sprite sheets assets. Number 2 is an easy number for the computer. That's why we advise you to use texture size, which are multiply of 2, because the computer needs less time to calculate those numbers. Ideally, texture size should be power of 2 on the sides. The textures do not have to be square. In example, width can be different from the height. Always use small textures if possible. Maybe your mobile device has large amount of system memory with flagship phone models, but also consider the video memory of regular smartphones. The larger the pixel size, the more video memory is used. If you double the pixel size, then it would take 4 times more of the video memory. The textures will perhaps have sharper lines, but it will have performance hit with less overhead for video memory. In texture settings, we use compression to reduce the size of textures. Also, make sure textures has its own compression settings set according to its corresponding usages. Now on mipmap settings. Mipmaps is almost like LODs for textures. It's widely used for speeding up render times by reducing texel sample to render each pixels and reduce stress on GPU and CPU. Depending on the use case of textures, we can adjust whether mipmaps are necessary to balance between the quality and the resource size. The same 2K textures will have different resource size according to whether mipmaps are generated or not. Following the general principle mentioned above, we always pack our UI elements or sprite animations into sprite sheets. In this case, power of 2 and dimension rules mentioned above will still apply to the sprite asset creations. Now we're going to start looking at code optimization for our games. Our focuses here are mainly on reduced tick counts, reduced physics, and utilizing soft reference whenever possible. To reduce strain on the CPU, we have to be careful with the way on how we make use of tick per second in the coding or blueprint. Here's an example in blueprint, whereby we should always avoid using event tick if possible. We should use set timer instead to reduce tick counts. Also, utilize event dispatcher to notify other objects instead of checking every frames. To further optimize our game, we also avoid unnecessary collisions in the game. We just need to disable collisions for each assets whenever it's needed, off-screen or in far distance. This will help us to squeeze a little more performance out of the mobile device.
Okay, to reduce the physics calculation in the game, you can manually set to enable or disable the object physics constraint at will. For this object, we will use a sphere collision, which will poll whether the pawn is entering the proximity of the object or leaving the object. By using the component begin overlap, we can know whether the pawn has entered the proximity of the object and enable simulate physics. And this timer will check whether the object will remain stationary or we will move according to the collision by the player. Okay. This on component head will set the collision response to the vehicle or ignore it completely. Okay, in this demonstration, the object is purposely hang over the air. When the player approaches the object, it will trigger the physics collision and simulate the free fall.
Memory in mobile device is always limited, so we must manage the memory by using soft reference in memory handling. It can help to reduce the memory usage at the cost of more load time asynchronously. Remember to use soft reference as much as possible to avoid overuse of system RAM and video RAM when launching the game. It also can help in minimizing the peak RAM usage of our game during installation.
Okay, hello everyone, and today I'm going to teach you how to use a soft reference in Unreal Engine. So here I have an example where I will have a widget, and then I will just have an image set up properly when you press the play button. So usually how you do this is you get your image, it is a paper sprite, and then you have your image background, and then you just straight away set it to it. By doing this, you are actually referring a hard reference through your data table, which means that every time you load the data table, that image will be loaded into memory. And that is something we actually want to prevent, especially in mobile games where our memory is actually limited. So to change this to become a soft object reference, in this use case, I'm using a structure called an F background. So in this structure here, you can see that we are using a paper sprite object reference. So to change it to a soft reference through this variable type, you can just type paper sprite again. And then when you hover this menu, there's a selection on the side, and then something called a soft object reference, and you can click on it. So this will now change to a soft object reference. And then when you check back to your data table, your things will be kept intact. Just instead of a hard referencing to the actual texture, we are now soft referencing to a texture. So inside, wherever you set your image, you will notice that it will become incompatible because a soft texture is not loaded into memory when it's referenced. That's why you need to load it yourself. So from a soft reference object, you can use two ways. There's actually a load asynchronously, and you can actually load blocking. Asynchronously means that things will be loading in the background, so your screen will not freeze. And then asset blocking, that means it will actually block the thread, and then your viewport will freeze until the file is loaded. In this use case, I will want to use an asynchronous loading. So you can just replace this in between the lines. You can load the soft reference, and then because when the soft reference is finished loading, you need to check its type. So we need to cast this to a paper sprite, and remember to connect this to the completed event. And then after that, you only set it to set your image. So with this, when you press play again, you see the same picture came up, but actually this time it's actually soft reference that you only will load it to memory when you need the files. That's it. Thank you.
The trickiest part of the optimization in mobile game is in the rendering optimizations. There are a lot more things that we need to take care of in order to maintain high performance and high fidelity of our game, namely like shading features, light complexity, shader complexity, quad overdraw, instancing, and light maps. First off, for shading features, we must disable unnecessary shading features in our Unreal Editor on mobile shader permutations reductions as seen in the screenshots here. Lights are always crucial elements in our game. The more lights we use, the more it will consume the performance of the hardware. Here, we use light complexity view mode to show the radius of the light sources affecting nearby meshes. The color representing the numbers of the overlapping radius of light sources. Reddish area means that there are multiple light sources affecting the region and needed more resources to calculate in pixel shaders. Higher overlapping counts are directly proportional to the shader's complexity. We must balance between static, movable lights, and assets in the level. Another interesting mode when it comes to rendering pixels is shaders complexity. The more instructions in the shader, the longer it takes to compile and update the viewport. It's generally taxing for translucent and mask material as it takes quad overdraw into account. We always find that mobile hardware don't cope well with quad overdraw. When our game draws the same pixels more than once with the same frame, it will greatly affect the performance of our game. Normally, geometry is culled when obscured by another object, but that is not the case with translucent or masked object. The renderer needs to render both masked and translucent object behind it, which can create a lot of overdraw if multiple masked and translucent objects are stacked in front of each other. We use instance mesh placed manually or procedurally in the levels and instance materials to reduce draw calls. Remember to use hierarchical instance static mesh whenever possible to conserve draw calls over large numbers of objects. Hierarchical levels of details can be used on top of normal LODs to bundle objects together at far distance.
Okay, for this type of instancing, we use a thing called spline, which can spawn a number of instances along the spline. In this scenario, we can see that if you drag the spline, it will spawn automatically to the distance specified in the settings. In this case, it will spawn a railing every 300 Unreal units.
As part of the method for optimization, we sometimes use big light maps in order to reduce real-time lights and shadows. However, more light maps will take up more texture resources, hence it will increase the final package size. Alternatively, we can implement light maps directly in diffuse or color maps in order to reduce the textures needed for light maps. We use debugging tools bundled in Unreal Editor and external device profilers in order to find out how does the game react in editor and also in actual hardware. We can access the Unreal Profiler from the session front end under Developers Tools. Here's how the profiler looks like. We use it to check for CPU and GPU time, finding issues in the code, base draw, post-process, instance count, textures memory, and to hunt down resource-hungry assets.
I'm going to show you guys how to use the Unreal Profiler. It's a pretty interesting tool, and it's indeed very powerful to decide to find out what happens in your game code that actually hogging a process. So I've actually made an example scenario here. When I press button spawn, I will spawn a bunch of balls at once. So those balls are also physics based, and then if we use the colon command, then we tag in stat unit, you can bring up the stat unit. So when we press the spawn button, you can see that the frame slightly goes up and then it comes back down again. So let's say in the game that you might have some scenes where you have the frame times spiking, then the Unreal Profiler tool which will be very handy to find out what's happening. So to do that, you go to your Windows and then Developer Tools and then a session front end. You bring up a window and we select your current session and then go to the Profiler section. So select your current session, which is the editor session. You can actually use this on different other sections, let's say a simulated one or a standalone one. So you can actually select them. But for this editor view, it's usually under this application and then you select the editor one. And then to start profiling, you can use the data preview and then it will start logging. Don't be afraid with the spike now here, because profiling also takes some of resource. If your PC is not strong enough, it will actually spike some. So when you go back to the game, you notice that the profiling is actually on, and then our current frame rates are like this. So when we play the game and then I try to spawn again, you can see there's a spike in the frames. You can actually use like stat raw to see the graph like spikes a little bit here, and then you can press stop. You can go back here and stop here, and then you can scroll this bar to where you see the spikes. So it's probably around here. Then you highlight the area you want to see, then you will see a bunch of stuff going on now here. So don't be afraid, it's actually only a few things you need to see. So first we change the maximum mode just to check that which one takes the most time. And then most of the time you will just need to check the game thread. And then for the easy button here, it will be like the hot path, which show you like the highest time taken within all the game thread, and then it will actually show up. So actually it's not doing that much, so you can try to find out more. So usually it's like in the frame time, and then you got like more take time. So around here there will be some spikes. Change to maximum game thread, and then you can see that there's a process mouse button, because the one that I press a button and then it starts spawning and stuff. You can check here that there's a like spawn function, and then it takes like how many calls of them on the site, and then basically you can just use this tool to find out that which part of your code is actually hogging your resources.
As for a device profiler, here are two external device profiler provided by Qualcomm and ARM for profiling mobile hardware specific issues. When we are ready to deploy our game to App Store, we need to package our game into APK or IPA for each platforms. We still need to reduce the size of our final packages in order to comply to App Store publishing requirements or the player download preference. When we are reducing the size of our package, we can build with hidden symbols, visibility enabled in shipping config. Then we can exclude editor content during cooking. When we are cooking, remember to check on cook only maps. And also remember to list all the maps included in the packages. Then exclude prerequisite installer by unchecking the checkbox. By utilizing pack blacklist, you can exclude unneeded content from package into the game that are otherwise not used in the game. We can use Unreal Pack binary available in the engine binary to extract and inspect the content of the pack from your package platform binaries. Check for content that otherwise not used in the production. For example, like the engine debug materials, engine tutorials, leap motion controller, unused fonts, editor maps. And as for default plugins that are otherwise not used in the production, such as Oculus, OpenXR, LiveLink, etc. Be careful when removing the contents because you might remove something that you needed in the production. In the Android platform, textures format for mobile devices should be handled by AAB, so no need for concern. Else, ASTC for general support for most devices on the market. Never ship packages with multi under Android. As for iOS, we can just keep it in default. As a result, here's an example of Unreal Engine MT project package sample to show you that before and after we have applied the procedures above. The OBB files has down from 32 MB to 15 MB, and the APK file has decreased from 80 MB to 48 MB. By the end, I would like to thank everyone who has attended my session. I hope that my sharing today will be able to help everyone to build better mobile games by using Unreal Engine. Hope to see you guys again in the future. Cheers!